Dr. Fraisse is a professor in the Agricultural and Biological Engineering Department at the University of Florida. The focus of his applied research and extension program is on developing and providing climate information and decision support tools to help agricultural producers better cope with risk associated with climate variability and change. Dr. Fraisse developed and maintains AgroClimate, a web-based climate information system, which you will hear all about today. So once again, at this time, I want to thank everyone for joining. I'm going to turn it over to Dr. Fraisse, and he's going to pull up the slides on his end.
Thank you. Thanks, Philip. I hope everyone can hear me okay now.
Yes, we can hear you.
Okay, I will share my screen here. Okay. All right. Okay, can you see this slide?
Yes, looks good.
Okay, thank you. Thanks again. And like Philip mentioned, welcome to this webinar, and feel free to ask questions anytime you have a question. Stop me. What I'm planning today is to go over some slides, of course, but then go to the website itself in the second half so that we can do some live demonstrations and make it more interesting for you as well. So a little bit to start about the history of AgroClimate. It has been, in fact, we started AgroClimate a long time ago. I was thinking, preparing for this seminar, for this webinar, back in 2003, 2004. Actually, the first version of this website was launched in 2005. And it was a project that was funded by the USDA Risk Management Agency, RMA. And the idea at the time was they had a program that would fund decision support tools for commodities that were considered underserved by crop insurance. And that's how AgroClimate started. We were primarily working with specialty crops. After that, we had quite a good funding from NOAA and also from the USDA NIFA with the Southeast Climate Consortium. And then many of the tools that we still have, many of the ideas that we're going to be discussing here today were put together during that time between 2010, 2016, 2018, when we had the consortium operating. And there was really an interesting project with several universities. In addition to the University of Florida, we had Florida State University, University of the University of Georgia, University of Miami, Auburn, Clemson University, Alabama Huntsville, and North Carolina. So it was a very exciting time for the group and for this project, when many of the ideas, and we had really strong interactions with farmers and with growers, and a lot of progress were made at that time. One thing that I always like to start is to say that what's our mission, and it has been evolving with the years, but we consider that our main mission is to increase action and add value to weather and climate data. We know that many times we need to collect data, first of all, to translate this into some sort of an action or a recommendation. And it could be, we started before with just weather station data. Nowadays, we have a lot of work with gridded data that allows us to go further to spatially. Also, we have restrictions in terms of temporal resolution, also how soon we get the data, etc. But if you just stop here collecting the data, that's what we call the descriptive analytics process, which basically you can explain what happened. Like if we look at this summer, we have had a very warm summer, so we can explain how high the temperature was, etc. But that's it. So we don't want to stop there. We want to move to the second phase, which is the predictive analytics, and where we can actually run models. We can simulate effects of this observed weather in our crops, or even if we have some forecast, we can simulate what's going to happen next. But also, modeling is very important because it allows us to do the what-if scenarios. What if it doesn't rain the next week? What if we have a high humidity or temperature threshold, a temperature in a different range? What does that mean to the crop with those conditions? It also depends on the phenology. What's the development phase? It depends on what sort of crop we have. If we are simulating disease, which is in this case here, disease risk. It also depends which kind of fungus we have, etc. So this put us in a much better position now to understand what's going to happen, what may be the situation. But actually, farmers are looking for this third step, which is what we call the prescriptive analytics. And that's when the decision is made, the recommendation is provided, and then something happens based on this process here. So it is sometimes we have to collect a lot of data to get to this point, to just make a basic recommendation here, in this case, like spray fungicide or don't spray. And so it's a lot of work to be here, but here's where the value is. Here's where the solution comes. And I always highlight the idea of solutions because we heard that from farmers. They want solutions. And that's what we try to do. Not always possible. Sometimes we don't get that far, but we always aim at getting to the point where a decision can be made with the information that we are providing. So just quick reminder here, we monitor and forecast, we simulate effects, and we take action. That's the goal for the system. This is a quick introduction there to the website itself. If you're not familiar, you haven't seen it, it's agroclimate.org. And this is a quick overview of this menu that we have. And of course, the main thing here are the tools. And if you click on tools, we have several different topics that we call. We have climate indicators, pests and diseases, crop yield and development, footprint calculators, and the project that was recently finished with WSU, where we look at climate change projections for fruit and veg crops. We do have forecasts. We don't produce any forecast, of course. We just facilitate the access to forecast, different forecasts in the system. A lot of what we do is based and was based since the beginning in the El Nino Southern Oscillation, because it gives us some ability to predict the season in many places, not everywhere. So a lot of the tools and insights that we provide are based on the El Nino Southern Oscillation forecast and phases. We do have links to some of the state climate offices where you can get some summaries and reports for different states in the Southeast. We do have several materials related to extension, fact sheets, etc. And I'll provide some basic information to you as we go. So what I want to do is to highlight a couple of tools here in the slides, and later on we can see that in the website itself. So when we look at the different tools that we have, I can tell you very popular ones. Some of them I consider more like educational tools. They are not used on a daily basis, but some are very much used, and one of them is the chill hours calculator. And also in pests and diseases, we have some tools that are very, very popular with specific commodities. So why chill hours? We have seen this. This tool is old, in fact. It has been up for the latest 10 years or so, and we are going to improve it this year. But the fact is that more and more we see a need for this information. And the main reason is that if we go to this is a total chill hours accumulated between October and February for for Alachua County here in Florida, and based on the Florida Automated Weather Network data. If you go to any weather station in Florida from the phone system, you're going to see similar trends. We have seen a decrease in the accumulation of chill hours, which is a major problem for temperate fruit, as you probably know. You may have seen reports from Georgia last year that production of peaches was very poor due to a lack of chill, and also the same problem happens sometimes with blueberries here in the northern parts of Florida, also southern Georgia. The other issue that we have with the warm winters it's really the fact that it may accelerate bloom, and then we have a freeze, and this has happened in the past 4 years ago, if I remember well, which was a major issue. So we accelerate the process, we have blooming, and then we have a late freeze, and this can be devastating. So this tool has been extremely popular. And one quick observation, if we look at this graph, you can see that the lowest chill accumulation we have in this weather station here in Alachua was in 2016. There was an El Nino year, in fact, a warm year. And we're heading the same way this year with the El Nino cycle. So this is a quick overview. Like I mentioned, this tool is very old. It does have some limitations, but at the same time, it's very simple. And I think that's another thing that we look for is simplicity, because, you know, we, in academia, we like too many graphs, we like tables, we like a lot of information, and sometimes we get too excited about that, and we better tone down this and provide simpler sort of information so that it's more efficient, more effective than trying to show too much. In this case, in this tool, you just select a weather station, either in the Southeast. There are several, not only in Florida, but some in Georgia, Alabama. And then you can select only hours, 2 hours model. Later on, I'll talk about other models that we are incorporating this year. Either one is the just hours below 45 Fahrenheit, but the most popular one is the number of hours between 32 and 45, because hours below freezing are not considered effective in terms of chill accumulation for the temperate fruits. What you will see is the current year accumulation. This slide was this year in I think I did this screen capture on February 9 of 2023, and you can see the brown line here. The maroon is the current accumulation at this point. That in that day I had 267 chill hours. The blue line would be last year, and the yellow orange line was the long-term average for this particular station. So you can see that we are below the long-term average, and this has been the history for the last 5 years or so in most of almost all the stations we have in Florida. So what our plans? We're going to redesign this tool. Growers asked last year we were in Savannah for the Fruit and Vegetable Conference, and they asked to plot for the ability to plot more years to see what happened in different years beyond the last year. And also we're going to use the dynamic model which is a model that was developed in Israel and Australia, I believe, back in the 80s, but it has been widely adopted in California, and it's supposed to work well, work better for places that have warm winters, like we have here in the Southeast. Other tool that it's very popular are the disease forecast systems. And we have the strawberries, blueberry, and some directed to citrus. The strawberry is the one that has been widely adopted in many places, and it's fairly simple. We're looking at two diseases, anthracnose and botrytis, and what you see is the risk level for different weather stations. Each marker here is one weather station in Florida, and the A is for anthracnose, B is for botrytis, and the colors will indicate if we have low risk, moderate risk, or high risk. And the growers can actually answer simple questions, and they will get a recommendation if they need to spray or not. And this tool has been expanded to other places in the US. Actually, it's also been working in Norway during the last 3-4 years. This year, we also started providing it in Denmark, in some other areas. So it has been very effective and very much interesting for growers. One thing that I like is that you can plot the risk level for different years using the tool, so we keep the history. And if you see here, what's the strawberry season here in Florida? It's from November through February, March. And if you look at the last 3 years, we have had very low risk in terms of, in this case, is anthracnose. And why is that? We have had 3 La Nina cycles. And if you are familiar with the La Nina effects here in the Southeast, you know that it brings more drier and warmer conditions. So primarily drier conditions is what has resulted in this low risk, some risk at the beginning of the season, then in most of the season we have had very low risk. So growers are spoiled, I would say, and this year they might have a surprise because we are expecting an El Nino year, which will change things, as we will discuss later in this presentation. One thing that we are trying to do is to use gridded data for this kind of tool. And this is a simulation. We use hourly data. In the weather stations, we use 15-minute data from the weather stations. Here, we use gridded data that comes from, in fact, from NOAA in this case. And it's an hourly interval, but it covers a large area. What are the drawbacks? The first one is that although it's almost like a nowcast, it has a delay. Once this is produced, we can ingest, we can process and plot risk. It will take at least 12 to 18 hours. So this is pretty much a limitation. No grower wants to have an information that, well, yesterday you had a high risk situation, you should have sprayed. That's not what they want. So we want to incorporate the forecast in this system. And that's taking a little bit of time. We need to evaluate. I have a student working on this now, but that's the plan. The benefits are, as you saw in the previous slide, you would only have this information for locations where you have a weather station, and if you, with this tool, you can have it everywhere, basically everywhere in the country, actually. So that's a benefit, but also there is a cost for this ability. Moving to the next one, we have some forecasts as well that, like I mentioned, we don't produce a forecast, but we display, we facilitate that. One of them is the cumulative precipitation expected for the next 2 days, 3 days, 5 days, 7 days across the country. So it gives you a visual This was done yesterday, and you can see here the expected rain in the ocean from Hurricane Lee. That's what we were expecting in Florida, about in the range of half an inch for 1 inch in the next 3 days or so across different regions of Florida. But also you can see that all over the place. Some rain in Texas, which they definitely need, and some other places as well. We also have the seasonal forecast. The seasonal forecast is for the next three months, 90 days. And this is updated. This is updated every month. The last one we had was August 17, so there's one coming probably this week, a new one. And it gives you the probability shifts for temperature and for rainfall. The way we look at this is if you don't know anything, you say, well, there is an equal chance of having temperature above normal, around normal, or below normal. The same for rainfall. So what this plot does, it's not a forecast, it's a probability shift based on the current conditions of the atmosphere and the ocean. And what you are seeing here is that for September, October, November, and in the southeast and the eastern side of the country, there is a certain probability shift, not very high, at least here in Florida, that we will not have then equal chances. We don't have a 33% chance, but there is a slight shift towards above normal precipitation and also above normal temperature. So this is how we see that, and we just facilitate the access to this information. There is also information about the El Nino southern oscillation. Many times growers say, well, okay, you say El Nino will bring more rain or less rain. It will modify the weather patterns, but they want to know in their backyard. And this was a study done several years ago where we looked at weather stations in Florida, and we plotted graphs showing the shifts for each weather station so that you have a more localized information. So this is a quick review. Most of you probably already know about the El Nino, but El Nino is a warming of the Pacific Ocean in the tropical area here that happens every 2 to 7 years. And what this one shows, a big El Nino that happened in 97, 98. Normally the strong effects come in the fall, winter, and early spring. And what you see here is actually not the temperature. Actually, this is the elevation of the ocean. This is what the satellite gives you. And it's above normal elevation, which also indicates above normal temperature. Normally, you would see a warm pool on this side, more towards the Australia. And here we'll have a cooler water. But when there is an El Nino, you'll see warming of the Pacific Ocean in this area. And this is well known. The teleconnections for this system is that it will bring wetter winter and springs in the southeast US. It also is connected with looking historically with fewer Atlantic hurricanes when we have an El Nino. The La Nina will be the opposite, will be a cooling. That's what we had for the last 3 years, below normal sea surface temperature. And this La Ninas normally are connected with warm and drier winters and fall and early spring in the US. So the question is, if you know that, how can we access the information for a particular location? And that's what we provided with this tool, which gives you, those are the weather stations. It gives you in this case, what you're seeing here. There are many pieces of information here, but this will give you the average rainfall, accumulation, monthly rainfall accumulation in Alachua County throughout the month for the different months during El Nino years. Many times, this doesn't tell you much. What we want to know is the deviation from the long-term average. So what this other tab would give you, or this other table, in fact, when you're selecting this tool, you see the deviation from the long-term average. And what you see here is that during January, February, March, April, you will see normally above average. Also in November and December, above normal precipitation in Alachua County, and not much of an effect during the summertime, and during the fall, you would see a trend towards below normal, and that's probably because of it doesn't favor tropical storms and hurricanes during El Nino, so you see that difference there. But look at the scale; it's important. It's not huge differences many times, but you see the trend. If we're looking at La Niña years for the same place, Alachua County, you would see a different picture with below normal or negative deviations of the precipitation accumulated during the spring and the fall semesters, and some above normal during the hurricane season, let's say. So this tool, it's available for many weather stations across the Southeast. So that gives you more detailed information, what to expect. It's not a forecast. It's important to mention that every El Nino La Niña is different, but that's the trend. That's what you could expect for those cycles. And there are many fact sheets, like I mentioned, explaining what's the difference between weather and climate, what's the effects of the El Nino Southern Oscillation, not only in the terms of climate effects, but also what are the potential effects on agriculture. I also produced an EDIS, or also a fact sheet on maintaining the farm weather station, and there's some other interesting pieces of information here. I will go over a few more slides, and then I think we can stop. And before we move to the website, there's one tool that is very recent. It's called Climate Indicators. And what it tries to do is put a lot of this information in a single tool. It's not, it's just a better version that it's available now. We're still working some of that, but it will give you, I think it will give you an overview, not only for the Southeast, but for the entire country. And it was done under a cooperative agreement with the USDA, Office of Energy and Environmental Policy that we had last year. So it has some other different indicators. This one was already available. It's a drought index. This one is not yet implemented, but we're also looking at nighttime temperature. We have seen in Florida a shift, not so much in the maximum temperature, but with the exception of this August, to be honest, and back in July, but a shift towards in the minimum temperature. We see an increase in the minimum temperature. That has been very clear for us during the last few years. And arid is more like a drought index. It's a soil water balance. We do that for the entire country. And it varies from 0 to 1. When there is a value of 1, it means that there is no evapotranspiration. So it's a high stress situation. And it's a simulation that's done for a grass crop using a root zone of 16 inches or 40 centimeters. This tool will give you the typical, what was accumulated for rainfall, for instance, since 2001, I'm sorry, 1981. And it goes all the way, showing the accumulation throughout the years for a given location that you can select and for a particular time period, but also you have the deviation. So this was a slide I prepared last year, so you can see this, in this case, it was the winter time in January and February, 1 month, and this year was below average, as it has been the last 3 years. And there are some other ideas as well, like maximum temperature, minimum temperature, dry spell, etc. But we can talk about this later. And also, like I mentioned in this tool, we already have different ways to calculate chill accumulation, selecting different temperatures, chill portions, chill units. This is a model that doesn't work in the warm areas. It's only for the northern parts of the country, but it's also available here, and some other ideas as well. I think at this point, I would like to stop sharing, see if you have any questions, and then we can look at the website, but it might be a good time to give you guys a break. And it's a good opportunity maybe to ask questions if you have any as well, that we can certainly discuss.
Yes, thank you, Dr. Fraisse. Yeah, I just want to come in and remind everyone that you can use the chat or the Q&A if you have any questions or comments or anything like that that you'd like to share at this time. So feel free to use either of those and just type them in.
I know it's a lot of information, and sometimes it's too much. So feel free to ask a question, and then I can go to the website, and might be more interesting to see some live demonstration. But the idea is that we keep evolve. I didn't mention that, but AgroClimate has been soft funded since the beginning with different grants. So it is a project that we have many different tools based on the projects that we are able to fund, and sometimes it goes in different directions. But we try to keep focus on the ideas that we had at the very beginning. No questions? Okay. Maybe we can go to the website there. Okay, can you see the screen that I have now?
Yes, we can see it.
Right. Okay, like this is the agroclimate.org that I mentioned at the beginning. Those are the different items in the menu. We also have some of the forecasts over here to facilitate, but also you can get to the forecasts over here using the menu, or the precipitation short-term forecast, for instance. Those are the ideas that I mentioned before. You can see what is expected in the next 3 days, 5 days, and it gives you an idea. This is when this might be useful. I would say planting season or harvest season. That's when we see farmers looking at this. You don't want to plant and have no moisture in the soil, or you don't want to plant harvesting when it's going to be raining. That's another problem. Or you want to get ahead of the rain in the harvest season as well. Seasonal forecast, it's what I already shown to you. So, I mean, this is updated regularly. As soon as they have a new update, this will be updated in the system. And also, another one that I didn't mention is the drought outlook. The drought outlook is the expected drought conditions for the country, and it's also updated every month. This one was released by the end of August, a few days ago, and it's valid through November 30. So that's the area where they expect some drought to occur, and very little things happening in the Panhandle. We have had, interestingly enough, very high temperatures, and also a little bit below average precipitation over there. And there is a corner here in the Southwest Florida as well. Hurricane forecast is just a replication of what is already available through other sources. So one thing that I want to show, and it takes a while, it's still working. We have our own map server for this, but this tool is the one that I mentioned. We have the beta version for that. It's a way that you can look at different variables in a mapping format or dropping a pin, which will give you the ability to look at the temporal variability of the indicators in a specific latitude, longitude. You can look at this as, for instance, it always default to the last 30 days, but you can choose other time periods that you want to look at. You also can look at the current observations or the deviation of this observation. So if I want to see where it did rain more or less than the expected normal for this particular time period, which were the last 30 days, you can click on this option, and eventually it will display you the difference in terms of rainfall observations. Like I said, I am in my Wi-Fi here, but still, even though it may take a little bit to display, and we are trying to optimize this ability. Since we are looking at the deviation, I think one that I wanted to perhaps look at is the maximum temperature. Let's see how fast it comes. But that was I was looking at this yesterday, and I saw some interesting information regarding the last 30 days, which has been very warm, especially here in the southern parts of the country. And you can see here already popping up some information. This is the deviation in terms of degrees Fahrenheit from the long-term average. And you can see it's amazing what we see here in Texas, Louisiana, parts of Mississippi. In Florida, of course, as well, we are above average. But primarily, like I mentioned before, here in the Panhandle, we can see they are, I mean, the anomalies have been higher over here than in some other parts of the country. And it's taken a while, but I think I saw some higher temperatures also in the Pacific Northwest in terms of above normal temperature. And you have some other variables we're not going to go over here, but it's like the stress degree days. So those will be degree days above different thresholds that you can also map chill accumulation. Of course, chill accumulation during the last 30 days, we will see nothing. You only see that in the winter time. One thing that I want to mention is this drop-a-pin. Basically, this is what I was saying, that if I pick a place here in the Panhandle, let's put it over here. Every time you move this marker, you have to load the data so that you update. This is what I was showing. Number one, you have an overview of the long-term average since 1981 for this location, how much rain we had observed between those different days, and you can change that. Let's say I just want to see from August 1st instead of August 8th through September 11th, 2 days ago, and you can see how much rain accumulated in this location for the different years. You can see the dry years, the wet years. You also see some basic statistics. On average, we have about 11 inches of rain in this location during this time. The wettest year was 2021, above 22 inches. The driest was 1990, 3 inches. And some statistics for the temperature as well, the minimum, the average, and the maximum. You can see the variability of the average temperature during the same time period. And also you can see maximum dry spell duration. So that's the number of days in sequence without rain. And for instance, in 2020, we had quite a bit, 7 days without rain during this time period here. Don't bother The month here is just referring to the particular year, but we didn't remove the month yet. And the maximum wet spell, which will be the maximum number of days between August 1st and September 11th for the same location. 2019, there were 21 days, 2021, 13 days. Very wet, and very, not in amount, but at least very, a good number of days, wet days in that particular year. We look at the deviation. Like I mentioned, I showed in this slide. So now you can see the years that were above and below average in terms of rainfall, in terms of minimum temperature. Like, this is what I was saying. I have seen this everywhere. The last almost 10 years or so, we see minimum temperature always above the long-term average. This is common in many locations. And with the maximal, you see, of course, same idea of this year, of course, very much warmer, but it's not such a clear trend as I see with the minimum temperature. If you go to these indicators, then you can plot information for this particular year, in fact, 2023. So now we're looking at this particular time period for this year, and this would be, you have different indicators. This is the maximum temperature if I want to see the minimum temperature as well. I have to load the data. So now you see this, or if you want to look at, let's say, growing degree days, and you can specify the base temperature. And also you could look at this. If it's something that makes sense to accumulate, you can look at the accumulation of growing degree days using 50 degrees Fahrenheit as the base temperature throughout that same time period. There are some other stress indicators like the temperature humidity index, which is used for dairy cows, for instance, if we want to see how much stress they may have had during that particular time. It might be interesting. So this tool is like being tested now. I didn't mention that, but you can create an account if you want and create a virtual weather station anywhere. So you would, the idea with this is that you will be able to come to this tool and you don't have to find your location anymore. You already have your station set. So you could always access the same location and keep track of what's going on there. One of the views I have for this is that if you don't have a weather station, or if you are far away from a reference weather station, you may want to use this to get started at least, and to learn what's going on. The other thing is that, again, this is all gridded data, and we have the limitations that I mentioned before. It doesn't represent the exact location, the exact information, because it always represents the average observations in the cell. And in this case, is a prism cell, which is about 4 by 4 kilometers. For the hourly data, is 2.5 kilometers. So it's between, let's say, 4 kilometers would be about over 2 miles, and 2.5 would be 1.3, 1.4 miles of grid size. Which explains also why it takes so long sometimes to load this, because it's a lot of data to plot in a map. Any questions for this tool, or should we keep going? Okay. This is a quick overview of some of the disease tools. I think that's something that people always look as well. This is the strawberry advisory system. Once you clear, you can have a tutorial. But again, like I mentioned, you have, oops, back here, information for different weather stations. And again, A is for anthracnose, B is for botrytis. And the color code here already gives you the level of this risk. This is for both diseases here for a particular station. This is for Baum. If I want to look at Bronson or other station, the Popka, you would have this evolution during the last 30 days, but you can choose different. If you want to go back, like I mentioned, if I want to see last year, you would be able to see that. We also provide a forecast of the risk for the next 48 hours. And this was a request because many times it's you don't want to learn, oh, we have a risk now. Should I go spray? Especially areas where, like in South Carolina, they were asking this when we were testing, that they have heavier soils and they cannot get the equipment in the field once it starts raining. So they want to know ahead of time. You can look at the weather for that location as well. You can export that to a CSV table, but that will give you the temperature, the relative humidity, the number of hours, the leaf wetness hours, if it's wet or no in that particular time. It takes a while. Once it's wet, it takes a while to dry. We expect 4 hours. After 4 hours, the risk will go to 0, and then we start accumulating again. And like I said, the recommendation is also here. If you have applied, let's say, during the last 7 days or more than 7 days ago, you would, in the case of anthracnose, you would need to spray fungicide. So this is what I was explaining at the beginning, the idea that you get to the point where you make a recommendation. That makes a tremendous difference in terms of how useful the tool is. The question is, you want to be careful here. Of course, we do work with the plant pathologists here. Growers will not take this blind in a blind way. They want to be able to test it first, and it's a slow process. It's not a quick. If it was just putting the model over there, it would be done very fast. But this requires, for being adopted, it requires more than just the website. I'll tell you that. And also, like I said, you can subscribe and manage your alerts in terms of which weather station you want to select. You can also, I remember well, here. I think it's here. Under my name, I can change a few things, like if I want to get it by email, by SMS, what days of the week I want to disable this, and time. Many growers, there was one request that they don't want to have the phone with a message, a notification between 11 p.m. and 6 a.m. Because they're not going to do anything about this, like a freeze alert. So they request not to be notified, and they can accommodate that request here. And also I can look at the log of the alerts I received in my case, so you can customize this tool as much as possible. Let's go back to it. So this is and we do have this for we're expanding for blueberries and other crops, some for citrus. But blueberries, the growers in southern Georgia also want to have that. So we are also getting some data from the Georgia Weather Network in order to provide this information there. Let me see. I think we are very close to the end. I have been talking for so long. lost track of time. So I think I will stop. One last thing, perhaps the extension materials, like I mentioned, if you want to look at the potential effects of El Nino on ag, we do have some information there, if it's a La Nina, if it is an El Nino, what during El Nino years you may have some interesting observations here. So there's a lot of information over there, but I will stop sharing now, Philip, and maybe allow some time for questions if there is any. But like I said, it's too much to talk, and it's also a long hour if I just showing this kind of thing.
Sure. Yeah. And we do have a few minutes left for questions or comments. So type those in if you have any. And once again, in the post-webinar email that I'll send out, I can send out the website. And so if those here, if you want to just kind of explore it more on your own time, you can certainly do that as well. But yeah, feel free to type those in. Dr. Fraisse, if people are typing in questions, I'll share just a very brief story that I thought of while you were speaking. You showed you're talking about the Enso cycles, and you showed a graphic of an El Nino from, I think you said 97, 98.
Mm-hmm.
And it kind of like triggered my memory, because I remember when I was a child growing up in Northeast Florida, we had some pretty severe wildfires in Northeast Florida in 98, the summer of 98. And I kind of was like, so I did a quick little search on that, and I did see that it was attributed to the El Nino, with pretty strong rains in the spring and dry in the summer.
Yeah.
But that's hindsight, right? That was 25 years ago. You're making predictive statements for growers now. Yeah.
It's interesting you mentioned this, because in 97, 98, we had this strong El Nino followed by a La Nina. 98, 99 was a La Nina year, very dry. So you're right, we had this rainfall in the year before, and then getting to the fall of 98, we got to a very dry period with the La Nina, which probably sparked what you just mentioned there.
Yeah.
We had another strong El Nino in 2015-16, and this one is expected to be strong as well. At least it's looking like it's going to be a strong El Nino.
Interesting. Yeah.
Yeah.
Which is, very, very applicable to growers and people who need to understand how that impacts their decision making. Yeah. So any questions or comments? I know we have just a few minutes left. Well, I'm not seeing anything come through.
Okay.
But
well, if you have questions or want to learn more about the project and what we are doing here in the program, feel free to contact me. I think my email was in the system there. I'll be happy to answer any questions later. I'll be fine.
Great. Okay, so there was a question from Sarap, and she said, how can we create an account in AgroClimate?
Yeah, you can, depending on, it would be an account in different tools. We don't have a general account for AgroClimate. So depending on the tool, some of them will have that. You can register. I didn't mention, but we have some apps as well, primarily for the diseases. And those allow you to create an account. We don't do it overall, just for specific tools that growers may want to be notified about. So that helps them in this process. But anyway, if you have an interest in any of those tools, if you don't find the right place, just send us a note.
Great. Well, Dr. Fraisse, any last thoughts before we close out today?
No, I think we are, this is, I hope that this was useful. I see more and more interest in this kind of information. We have seen more weather extremes happening all the time. And I think that this kind of information is from us or from anyone else, it's becoming more and more required and requested.
Wonderful. Yes. Yeah. Very, very important resource. So, well, Dr. Fraisse, thank you so much for coming on the Southeastern Coastal Center's webinar series and sharing this with us. And I want to thank all of our participants as well. And we'll get the recording out. So at this time, we'll go ahead and end today's webinar. Have a great rest of your day.
Thanks, Phil. Bye-bye.